Good morning, everyone. So let's talk about the grades for exam one. It went very well. We had 9 A's, 1 B, no C's, 1 D, 1 F. These are the actual grades for students sorted from highest to lowest. I have not added any bonus. I did offer bonus to students who stuck around for the end of class last time. I'll put those in later. And let's see, the average on the test was an 87.6. So it went well. I don't think there's much to talk about here. Does anyone have any questions? No?
Oh, if we did the bonus questions, it'll be added like later on.
Yeah, I'll add it. I just didn't get to it. I was just trying to get these graded and had some other things to do. So I'll put those in. It probably won't be till next week because I'm going to be going out of town tomorrow. So, and I won't be back till Sunday. So probably next week. Okay, so we were talking about proportions last time, and I had given everyone these two bonus problems to try and do on their own, and I just wanted to start class with those. I'm just going to go through them, and then we'll continue with the rest of this section. So the whole idea last time was that first we started talking about ratios, and then percents, and then we were talking about proportions. And so problem like number 12 said, where it says one plain bagel has 320 calories, how many are in 2.5 bagels? So the way we set this up is we start out by using the given ratio that one bagel, I'm gonna put 1B for bagel, has 320 calories. Or we could write it the other way, that 320 calories are in one bagel. So this is what we'll use to solve the problem. Now we need to figure out what we're looking for. So we're trying to find how many calories there are in 2.5 bagels. So that means we're going to use this ratio because calories is on top. And since we're trying to find the number of calories, that's the one we use. So now what we do is we write down how many calories, which I'll call X calories, over, hold on, let me do something real quick. Okay, here we go. X calories over, let's see, we have 2.5 bagels. So I'm gonna put 2.5, okay? And then I'm gonna say that must equal this ratio here, 320 calories to one bagel. And then what we can do is just look at this as numbers, forget all the units for a moment, and then do our little cross multiply. So 1 times X is X, and 2.5 times 320 is 640, 750, I think. Just double check this. My arithmetic doesn't feel like working today. 800, how the hell did I get that so wrong? 800 calories. Here we go. Okay. Now the next one says a leaking pipe can lose 24.7 gallons of water in 1 week. So again, this is our given ratio. I'm going to put 24.7 gallons in 1 week, or I can do 1 week, you lose 24.7 gallons. About a year ago, we had a water leak in our house in the middle of the night. One of the hoses going to the toilet ruptured, and we lost 2,000 gallons in about 6 hours and woke up to a flooded house. So 24.7 gallons in a week. I wish that's what the leak would have been, but anyway, okay, going on. We want to know how many gallons are lost in 30 days, right? So does someone see where there's kind of an issue with this?
13 days and the other one's 1 week, so it's counted in a different way.
Yeah, we have different units for the measurement of time. Here we're given weeks, but we're asked to discuss how much is lost in a certain amount of days. So we either need to convert everything over to days or everything over to weeks. And I think it's easier to turn our given ratios into days. So just change 1 week to 7 days. And change this 1 week to 7 days. And now everything is going to be with days. So how many gallons? We'll call that X over the 30 days must be equal to, okay, which one do we use? The left one or the right one here? Which of these two ratios are we going to use if we're trying to figure out how many gallons there are?
Oh, the first one.
First one, right? The one that has gallons on top. So 24.7 gallons. I'm not doing the units right now. I'm just doing the numbers over 7 days. And then we cross multiply. So 7x equals on our calculator 24.7 times 30 gives us 741. And then we divide both sides by 7. And you get 105.86, I'll say, gallons. Are there any questions on that? Darshell, I updated your grade, just so you know.
Yes, sir. Yes, sir. I just saw it.
Just make sure on the next test that you submit everything as a single file.
Okay, 1 by 1.
But no, you need to get it as a single. We can talk about it later after class. I don't want to talk about it now because, but just a different format, the way you send it to me, and everything will be okay.
Okay.
Right? That worked out.
Thank you.
Okay, so we're going to move on. Applications of percent. So we're going to be talking about percents in this little section. And this is actually, these two are formulas, and I'll allow you to have these on your exam. Your next exam, you can have these. I'll provide them for you. These are actually things that we use more often than you think. Anytime you buy something, or a price of something goes up or down, this is something that can be used to determine like the total that you spend maybe buying a new TV, or if you want to know how much gas prices have gone up, something like that, you can use these formulas. So the two formulas we have here, the first one here is how to figure out the total if you have to pay tax on something. So you have the price that it's being sold for, plus the price times the tax rate, and that will give you the total that you're going to pay. So that's our first formula. Sometimes we write this formula like this: P plus P times R equals T. So price plus price times tax rate equals T. The important thing with this formula is that when you do the tax rate, it must be a decimal. Because a lot of times taxes are given to us as a percentage, but you want to convert it to a decimal if you're going to use the formula. We'll do examples, don't worry. Now, the next one is how you determine the percent that something goes up or down. So if you want to know, you paid a certain amount for gas a couple of weeks ago, and now you paid more. You want to know what percentage it changed by. Then what you do is you take the new price, subtract the old price, and divide by the old price. And that's going to give you, and then multiply times 100, and then that'll give you your percent. Now, if this turns out to be a positive number, that means that it went up. And if it turns out to be a negative number, then that means it went down, it decreased. And that's it. Those are the two formulas we're going to use for this section. So let's take a look at the first problem here. It says here, Amy bought a pool hall for $219,765. I don't know who came up with these problems, but I guess somebody bought a pool hall. Imagine it's a big building with pool tables in it. I don't know. This price includes a 5% state tax. What was the price of the pool hall before tax? Okay. So remember, Amy's going to pay the price plus the price times the tax rate, and that will equal her total. What are we given in this problem? What are the two numbers we're given? This in yellow and in green. So who wants to tell me what we have, what the yellow represents here?
Price.
So is that the price she paid for? Is that the price, or is that the rate, the tax rate, or is that the total that she paid? Here's the question.
The total?
For $219,765. This price includes the tax.
So it's the total.
So that's the total. Okay, this right here is the total. And then what's the 5%?
The tax rate.
That's your tax rate R. Now, we do need to convert that into a percentage. So converting percentages into decimals, what you do is you take the percentage, you see where the decimal point is, and you move it 2 places to the left. So we get 0.05. I don't know why for some reason my thing is really writing weird today. Let's see, let me try this again. Okay. So R is equal to 0.05. And they're asking, what is the price? What was the price it was sold for? Like, how much were they asking before tax? So that is P. That's what we want to know. Does that make sense in the problem? Is that all clear to everyone? Any questions? I'm going to rewrite the equation. Okay, here we go. P, I don't know what P is, plus P times the rate. I do know the rate is 0.05. That must equal the total, which I know is $219,765. So we want to try and solve this for P. So watch what I do here. I'm going to multiply P times 0.05. This means I'm going to get P plus 0.05 times P. I'm just rearranging. I'm putting the 0.05 in front of the P. Equals 219,765. Now, this is a linear equation. Okay, so we've talked about how to solve these before. We want to, in this case, we want to combine these two together. So all we do to combine those is we look at the coefficients. We look at the numbers in front and add them. So we're going to take the 1 in front of this P, add the 0.05. That gives me 1.05. P equals 219,765. And now to get P by itself, I will divide both sides by 1.05.
So we make that 1 into a 1.05. Why is that?
Well, okay, so like if I asked you to add this together, 2x plus 3x, are you comfortable with the idea that that's 5x? Right? So all you did here was you took the 2 in front and you added the 3, and that's how you came up with the 5, right? So when you look at this P plus 0.05P, this P has a 1 in front of it. This one has a 0.05. So I add those together, and that's what gives me the 1.05. So it's the same concept. Good? Okay. So now I'm going to need my calculator. I'm going to do 219,765. Divide that by 1.05. And I get P is equal to 209,300. There we go. And this is dollars. So that means when Amy went to go buy this pool hall, they wanted $209,300 for the pool hall. But she had to pay taxes on it. So she walked out the door spending $219,765. Could we figure out from that how much she paid in tax? Like how much tax she actually paid?
Yes, you subtract the 209,300 from, I mean, the 219,765 from the 209,300.
Yes, you said it right the first time. You're going to subtract the 209,300 from the other one, and you get,
Okay.
yeah, you get 10,000. So if I wanted, and I'm not asking for this in the problem, but if we wanted to know just for our own sake, she paid $10,465 in tax. That's how much the tax was. It's a lot of tax. Okay, we move on. Steve needs to buy his sister a birthday gift from the mall. He sees a shirt that is normally priced at $24.50, but it's on sale today for 20% off. If the sales tax is 8.25%, how much will Steve pay for the shirt? So think about this. The shirt's normally $24.50, but it's on sale. So it's 20% off. So we need to take 20% off of $24.50. And then we apply the tax to that. Okay, so it's important we get the order of things right here. Get the shirt, figure out how much it is with the discount, and then do the formula, you know, P plus PR equals T. We'll use that formula, but this P here has to be the sale price. So how can I figure out what 20% off of this is? I'm curious to know what people would do. If I told you this was a price, but we need to take 20% off, how would you do that? Any ideas? Kind of two ways. There's a hard way and an easy way, but the easy way is not, most people don't do it.
Before starting it,
Go ahead, Lewis. I'll go with Lewis first. I think I heard him first.
Only multiply?
Okay, multiply. You say you're going to multiply 24.50
Yeah,
by what?
20.
By 20? Do you want me to do 20 or you want me to convert it to a decimal? If you multiply that by 20, it's going to get huge, isn't it?
Yeah.
That's 20 times this. You don't want 20 times this. You want a smaller percentage of it. So whatever 20% is going to be smaller than 24.50.
Okay, yeah.
Right? So I think what Lewis is saying is take 24.50 and multiply it times 20%, which is 0.20. Let's do that and see what we get. Let's just see what that is. 24.50 times 0.2. I'm getting $4.9 or $4.90, $4.90, right? That is correct so far, but that's not the price we're going to pay for the shirt. Lewis, what is this? What is the $4.90?
That the amount you take off?
That's the amount I take off, right? That's
Yeah.
the discount. So I need to now take the 24.50 and subtract the 4.90. Let's do that. And you get 19.60. Okay, this would be P. That would be the price. Now we still have to pay tax on that, right? So I'm gonna use that in this formula in a second. Does anyone have any questions on that? Does anybody know an easier way to get that same number? Think about it this way. If I'm going to ask you to take 20% off, right? Then aren't you really only going to be paying for 80% of the shirt? To say take off 20% is the same as saying pay 80%. Y'all agree with that idea?
Yeah.
Okay, so why don't we try that? This is a different way of doing it. Why don't we take the 24.50 and multiply it times 80%, which would be 0.80, right? Again, we don't multiply by 80, we have to convert the percentage into a decimal. So if we do 24.50 times 0.8, what do you know? We get the same number, right? That's faster because when you do the 20% like this, you have to figure out this number, then subtract it from the original number to get this answer. Where if you do it this way, you get to it straight away. Does that make sense? So if something were, let's say you go to buy something at the store and it says it's 15% off. Instead of trying to figure out what that is, just take that price and multiply it by what? If it was 15% off, you'd multiply by what?
85.
85 or 0.85, right? And that would give you the total. So it's just, I don't care which way you do it, okay? As long as you get the right answer. I'm just giving you a suggestion that I think this way is faster, more efficient. Okay, now we're ready to plug in here. Now this 8.25 is our tax rate. So I need to move the decimal 2 places, 0.0825. That's what R is. And now I'm ready for the formula. So P is 1960 plus 1960 again times R, which is 0.0825. That will equal our total. Now, order of operations, make sure that you do this multiplication before you try and add anything together, right? That's multiplication. So on my calculator, 1960 times 0.0825. I'm going to get, let's see, 1960 plus, I'm getting 1.617, so I'm going to round that to 1.62. And then I add the 1960. And I get 2122 is the total. So the shirt that's normally $24.50 is 20% off. And after tax, we wind up paying $21.22 for it. So I'll tell you a true story. It happened actually recently. So let me do it. Let me get a new page here. So in December, I decided that it was time to build a little shed, or it's more like a garage in our backyard. It's like a single car garage. And so I had to buy a ton of materials, and I bought a lot of them from Lowe's. And I had this coupon, and then I had these other discounts that I could get. Okay, so my total, and I'm going to just round this number around, you know, just to throw a number out here. My total was about $4,000. Okay, is how much I was going to spend on all these materials. All right. So I did it with one purchase. I put all my material list together and I made the order. It's 4,000. And I had two different options as far as discounts. I had a 20% off coupon. And then I also had two 10% offs. So I had a coupon that was 20% off your entire purchase. And then I had two coupons that they were going to let me use that were both 10% off. So the sales associate there at Lowe's said, it doesn't matter which one I use. They're the same thing. So do you agree or not? Is 20% off the same as taking 10% off twice? Well, it turns out it's not. It's not the same. So let's see why, okay? So, oh, this is 20% off. So let's do the 20% off scenario first. So using the idea that we just used with that shirt, if the total was 4,000, how could I figure out what 20% off would be? What could I do with the 4,000? Multiply it by what?
If you multiply it by 80.
0.20.
Okay, I can do 0.20, but what was the faster way?
Oh, if you multiply it by 80%.
By 80%, by 0.8, right? So instead of 20% off, I'm just going to do 80% of it, which is, what is that? $3,200. Okay. So they look at my total, they say, oh, we're gonna take 20% off. There it is. Now I still have to pay tax on it, okay? But let's not even worry about that. That's what we call our subtotal. That's before taxes. That's my 20% off coupon. Now, the way this works is that they ring up the total, then they first do the first coupon. So they take 10% off. So taking 10% off would really be the same as multiplying by what? Short way. 10% off.
90%.
90%. So multiply it by 0.9, and what do you get? So do that on your calculator, blah, blah, blah. You should get 3,600. Okay, so that's where we are. Then they get the second coupon and they apply that to that total. So 3,600, multiply that by 0.9 again. See, my second coupon goes through. And so let's see what we get here. 0.9, oops, 0.9 times 3,600. And I get 3,240. You see that? Any questions on what I did? These aren't the same, right? Because of the way the system worked, doing 10% followed by 10% again is not the same as doing 20% off the original. So I told the associate, no, it's not the same. They didn't agree with me, but I said, here, just use the 20% off. Because that saved me what, 40 bucks? I'll say 40 bucks that way, you know, which, hey, 40 bucks, right? It's a dinner, I guess. Okay, the only reason I showed this to you is just, again, to illustrate how when you have discounts, it's easy to get the total if you just kind of think about the other way. Instead of subtracting it, just think about what you're paying for instead of what the discount is. Okay, I hope that makes sense. Okay, let's get back to the packet here. All right, so Thomas is selling his Honda CVR on consignment by leaving it with a dealer who will get 25% of the selling price. What must the selling price be in order for Thomas's share to be 1,475? Okay, this is a somewhat complicated problem. So do y'all know what consignment is? If you don't, it's basically like there's like consignment furniture stores where you can go take your old furniture and you can give it to them and they'll say, yeah, that looks good. And they'll put it on their floor of their store and they will sell it for you. And if it sells, they will give you a certain percent and they will keep a certain percent. So consignment means someone else is selling it for you, but they get a cut of the sale. So Thomas is selling a car, I guess, on consignment, meaning he's giving it to somebody else to sell for him, right? The dealer. Okay, the dealer will get 25% of the selling price. The question is, what must the selling price be in order for Thomas's share to be this? This is tricky. I want you to think about it for a minute. I'm going to give everyone like a minute to think about it, maybe 2 minutes, and then maybe I don't know if I want to call on someone for this. Maybe I'll take a volunteer, but take a minute or two to see if you can figure out how to go about this. You can do it with the shortcut. I'll give you that hint. Okay, do I have any volunteers to help kind of explain their thinking on it, or you all stuck? Anyone? Cheyenne?
Wouldn't, this is for 16, correct? Let me just double check before I,
Yeah. Yes, 16.
wouldn't you multiply the Thomas's share by 1.25 for shorthand?
By one, so what's your thinking there? Why 1.25?
So because we're not trying to find 25% of whatever this is, we're trying to find what the actual selling price is.
Okay,
We'll give him this number. So the actual selling price will have that 1.25 in it. So it's going to be that plus whatever 25% is.
okay, that's a good thought. You're saying take this and multiply by 1.25, yes?
Yeah.
Okay, so you're basically saying 100% and then 25% together, that's 125, 1.25 as a decimal. Let's see what we get. Let's just see if this works. 1475 times 1.25, and you get 1843.75. So Cheyenne is suggesting that that's the selling price. Okay, right? Is it correct? Let's see. Is this correct? How can we check? Well, what is Thomas's share? What is Thomas's share? How much of it is he going to get? What percentage is Thomas getting of the sale? If the dealer's getting 25%, what's Thomas getting?
Is he getting the 75%, like the leftover?
75%, right? So what is 75% of that number that we came up with just now? Well, how do I do that? I just take 1843.75 and multiply it by 0.75 and see what I get. So take 1843.75, multiply that by 0.75, and I get 1382.81 something. So something seems off. Cheyenne, do you see what I'm saying? Like this is what is being suggested it sells for. But the dealer keeps 25%, so Thomas only gets 75%. So 75% of that selling price is 1,382.81, but that is not that. Do you see what I'm saying? So something's off. That's good thinking, but something is off there. So back it up for a second. We want to know what the selling price is, right? We want to know what that is. What's the selling price? But what we know is that Thomas only sees 75% of it, right? So we want to take that selling price. We want to see what would happen if we multiply it by 0.75. That should be equal to how much we want him to make. So the selling price, 75% of the selling price is Thomas's share, right? I'm going to write that down. 75% of the sell price is Thomas's share of the money, right? And we want that to be equal to 1475. So 75% of the sale price is exactly the sale price times 0.75. So how can I get the price by itself now? If I'm multiplying by 0.75, how can I get the P by itself?
Wouldn't you multiply P times 0.75, get it together, and then isolate it?
Okay, so you're saying just, this is 0.75 P equals 1475. That's just rearranging it. How do I get the 0.75 out of here? What can I do on both sides of the equation?
So you would divide 0.75.
Divide both sides by 0.75. Exactly. And then P would be 1966.666. So I'm going to put 67. There it is. So we would have to sell the Honda CRV for $1,966.67 in order for Thomas to get $1,475 from the sale. It's complicated, Cheyenne, because I understand what you're doing here, but it just doesn't quite work out that way. You can't incorporate the 25% in this way. So I hope this makes sense, how that little shortcut way of looking at things can help you solve something that's seems a little difficult. Okay, let's look at number 17. In 2004, Javier bought a new television set for $2,500. In 2012, he purchased a similar model for $950. What was the percent decrease from 2004 to 2012? So we're looking for the percent decrease, which is that other formula that I had put up there earlier. It's new minus old over old times 100. So in 2004, he bought it for $2,500. 2012, he bought a similar model for $950. So what's the price of the new model, the new TV he bought? What's that price? That's the $950, right? Then we're subtracting from that the old price, which is $2,500, and we're dividing it by the old price, which is $2,500. And that will be equal to, let's see, we just do this on our calculator, 950, take away 2,500, right? On top, you're going to get a negative number, right? Negative 1,550. And then divide that by 2,500. And you should get negative, oh, sorry, I forgot the multiply by 100. Sorry. And when you do that, you should get negative 62%. It's a negative number, which means that there was a decrease. I did all this on my calculator, and then after I did all that, I multiplied by 100. So when I did this, I got negative 0.62, and then I multiplied that times 100 and got negative 62. So that's a 62% decrease in price. Let me see here. I'm gonna look for something real quick. Give me just a moment. Where is that? Trying to show you something here. Oh, here we go. Okay. So I told you I was building a shed back in December last year, and this is me putting together all the different materials I needed. So I had to buy 2x4s, two pieces of wood, 2x4s, 8 foot long. I had to buy those from the store. I actually needed 48 of them. I don't know if y'all can see this. So I had to buy 48 of these 2x4s, and the cost at the time was $5.36 for one of them. So the total I was going to spend was $257. So all I want you to remember is one 2x4 in December, okay, cost me $5.36. So I'm going to write this down. I'll just do a new page here. So one 2x4, 8 foot long, was $5.36. And this was at Lowe's, okay? And this was in December of 2020. All right. So I haven't looked at this, but I'm gonna look at it right now. We're gonna look at it together. We're gonna go to Lowe's. And let's see how much a 2x4 is now. 2x4x8. Untreated lumber. There it is. Oh, whoa. $8.79. Okay, have you all heard? I'm sure you've heard in the news, prices for everything's gone up, right? Everything's becoming has gotten more expensive. $8.79. What percent increase is that? So we have now, same thing is $8.79 at Lowe's. And what's we're 2021. So that's 6 months later. What's the percent increase? Why don't you see if you can figure that out for me? What's the percent increase? I'll give you a minute. So what is, I'm going to call on somebody randomly. New minus old over old times 100. Give you about another 30 seconds. Elisa, I got your text or your chat. Thank you for letting me know. Okay, I'm gonna call on someone. I'm gonna call on someone that I haven't called on in a while. Let's see here. Let's see, Luis has already responded today. How about Lily? Is Lily here?
Yes.
Hi, Lily.
Hi.
Were you able to get the percent increase?
Kind of.
Okay.
I wasn't really paying attention during this one.
Okay.
So,
So no, you didn't?
no.
Okay. All right. Let's see. Emily?
I think that's me, but because I
Okay.
go by.
Okay,
Yeah,
remember
yeah.
I changed the names. The file didn't save. I had my power went out before I could save the file that day.
I think I got like 63%, but I'm not really sure.
Tell me what's your calculation. How did you do the calculation?
I just did the 8.79, like
That's your new price. Minus,
minus like the old price.
okay, and then over what?
Over like the old price.
Over the old price. That's the calculation, then times 100.
Yeah.
So when you did all of that on your calculator, I'm going to do it and then you can tell me what you got. Yeah, crazy. Okay, so what did you get?
I got the 63.9.
Yeah. Yeah, so you should get 63.99, something like that percent. A 63% increase in 6 months. 100% increase would mean the price doubled. Okay, that's what 100% increase means. A 63 means it's 63% more expensive, right? That's crazy. Let's do one more because this is fun. It's not fun, but okay. I also had to buy the sheathing, which is the stuff that goes on the roof. And I had to buy 15 sheets. They were $28.65. Okay, $28.65. I'm gonna look that up real quick. 4x8 sheathing. Let's see what happens here. See if we can find the cheapest one. It's OSB. I'm only doing this just to show you like real world stuff instead of me just doing stupid examples all day. I guess we could go with this one. This is not good. That's plywood. It needed sheathing. So this looks like it's the cheapest one, $49.75. So real quick, tell me the percent increase. And I'm going to call on somebody here in a minute. I'll just give you 1 minute to do this. What's the percent increase? How about Jamal?
Yes, sir.
Are you calculating it still?
Yeah, I'm still doing the math.
Okay, let me know when you got it.
I got 73.64.
Okay, good. I got the same thing. Anyone else? Or 73.64, and we'll put percent, right? So everyone should got, anyone not get that? Need to run through the calculation or no? Everyone good? So, I mean, look, this went up by 63%. This one went up by 73%. Everything's gone up. So remember I told you cost, what did I tell you it cost me? I priced everything out. What was it? Like, I forgot. 4,000 is what I said I paid about for the shed in December. If I were to do that now, it would cost me at least 6,000, at least. Maybe more, because everything's gone up so much. I got lucky. I wasn't expecting that to happen. I just got lucky. So that's percent increase. I hope that makes sense. I hope that real world examples kind of helped a little bit there. The next one we won't do, gas price increase from 325 to 405. What's the percent change? Okay, so that's basically like what we just did. Okay, we're gonna move on to mixture problems now. All right, so mixture problems are always confusing to students, all right? So let's read this first problem, number 19, and then we'll see if we can wrap our heads around this. You're mixing 1 gallon of 100% apple juice with 1 gallon of water. How much total liquid results, and what percentage of this is juice? Okay, so let's start with that one. Let's just ignore that for now. Okay, so we have 1 gallon of pure apple juice mixed with 1 gallon of water. At the end, how many gallons do we have? And what percentage of it is apple juice? So what do y'all think? Can y'all just think through this one? How many gallons would we have?
Wouldn't it just be 2 gallons and then
2
50
gallons?
is the juice?
How much, what percentage of it would be apple juice if we've mixed it?
50%?
50%. Okay, that's correct, but we need a more systematic way of doing it. Those numbers are easy to work with. So I'm going to try and get you to see this visually. We have this container that holds 1 gallon. I'm going to put 1G, okay? And it's filled with apple juice, right? It's filled with apple juice. It's 100% apple juice, which means everything in it is apple juice, right? And then we're going to add to this another gallon, right? And this is just pure water. So that means there is 100% juice. I'm gonna put J for juice in there. What percent of juice is in here? What's the percentage of juice in the other gallon of pure water?
0.
Is it 0?
0%, right? 0%. There's no juice in that one. Now, when we add the two together, we get this container that now has 2 gallons, right? And the question is, how much of it is apple juice? Because there's apple juice mixed in here with water, right? They're mixed together. So what percent is apple juice? So the way we do this is as follows. We go back to the beginning and we take the 1 gallon and we multiply it times this percentage of juice written as a decimal. Okay, so what's 100% written as a decimal? 100%. Move the decimal point 2 places. As a decimal, this is just 1, isn't it? Right? 100% is 1. So I'm going to take the 1 gallon and multiply it times 1. That comes from here. And that gives me 1 gallon. So what did I just do there? I was asking myself, basically, from this computation is telling me how much of this 1 gallon, how much of it is pure juice? Well, the whole thing is pure juice because it's all apple juice. You'll see how this works in a minute when we do something else. Now, over here, okay, over here, how much of this is juice? Well, we take the 1 gallon and we multiply it times the percentage, which would be 0, and 1 times 0 is 0. We take these two answers and we add them. So what's 1 gallon plus 0 gallons? Get just 1 gallon, right? So we have 1 gallon of juice. Together, we have 1 gallon of juice when we add them. So when you look back over here on this side, when we mix them, there's 2 gallons total, but there's 1 gallon of juice in here. So to figure out the percentage of juice, you do a ratio. 1 gallon of the 1 gallon of juice divided by the 2 gallon mixture. 1 divided by 2 is 0.5, and written as a percentage, that's 50%. Now, I just went through that first one. I'm going to do another one, okay? And then maybe if we do a few of these, you'll start to see how this works, okay? I'm going to skip this second part for now, and I'm just going to make up my own problem. Same juice situation though. Okay, so what if I have 4 gallons of 80% juice mixed with 3 gallons of 20% juice. First question, how much do we have? Second question, what is the percent juice? Okay, again, I'm going to work through this one. After I do this one, hopefully you'll understand how this all goes together. So think about the first container. It has 4 gallons in it. And what's the percentage of juice in that? In the 4 gallon mixture, it's 80%, right? We're going to add to that another container that has 3 gallons in it, and it's a 20% mixture. So how many total gallons do we have? And when we mix these two together, how many total gallons do we have? This is the easy part of the problem. How many total gallons are there?
7.
7, right? Just 4 and 3, we get 7. So we have 7 gallons in our mixture. That's when we add them, we've got this mixture and this has 7 gallons in it. The question is, how much of it is juice? Okay, how much juice is in here? So you have to go back and you have to look at each of these and figure out how much juice was in each one of these. So I'm going to take the 4 gallons here and multiply it times the percentage, 0.80, and that will tell me how much juice was in the first one, 3.2 gallons of juice. Remember, what we're doing is we're saying 4 gallons. If it were 100% juice, then this would be 4 gallons. If it were 50% juice, this would be 2 gallons. But since it's 80% juice, we have to multiply it times 0.8 to get how many gallons of it is juice. And we do the same thing on this one. 3 gallons times the 20% should be equal to 0.6 gallons of juice. Oh, I didn't spell juice. You with me? Questions? We have 3.2 gallons of juice in there. We have 0.6 gallons of juice here. When we add the two together, how many gallons of juice do we have when we add these? You just add 3.2 and 0.6, you get 3.8, right? We have 3.8 gallons of juice. Within this mixture of 7 gallons, 3.8 gallons of it is juice. So to find the percentage, I take the 3.8 and divide by the 7. And I get 0.5428, so I'm gonna say 0.543. Convert that to a percentage, 54.3%. Any questions? I'm going to give you one to work. So I want to make sure I can answer any questions like why I did a certain thing or. Okay. Trying to see which one I want. Okay, how about that one? "20 pints of a 2% saline solution is mixed with 15 pints of a 9% saline solution. How many pints are in the final mixture? What is the percent of saline in the final mixture?" So saline is salt. All right, so we're taking 20 pints of salt water and we're mixing it with 20 pints of water and 2% of it is salt. And we're mixing it with 15 pints of water where 9% of it is salt. And at the end, we want to know how much is in the final mixture and what's the percent of salt. So take a few minutes. Let's say, I don't think this will take more than 5 minutes, but I'll give you 5 minutes. All right, see how it goes. And then I'm going to call on somebody.
Sir, is it possible to look at like one of the ones that we just did? Yeah. Okay. Yeah. Sorry. You're like answering my question as you're doing it.
Yeah, sorry, I was on mute. I was talking. But yeah, I'm going to put this here so you can kind of see it next to one that we did. Just got to make it all fit here. Is that good?
Yes, sir. Thank you.
Okay. All right, there we go. Okay. Need more time or are we good? Any questions? All right, let's call on somebody. Let's see, is Piero here? I don't see Piero. Or Sergio. I think Sergio's not here in this class. How about Evelyn? I don't think I called on Evelyn last class. Is Evelyn here? Don't see Evelyn. How about Cheyenne? Cheyenne, you already participated today, yes? Did you get it
Yeah.
though?
I think so.
You want to just tell me what you got and then we'll see if other classmates got the same thing?
5%.
5%? Well, why is that not doing? All right. This thing's acting real weird today. Anyone else get 5%?
Yeah, that's what I got.
Two.
Yes,
Yeah.
sir.
Okay, good. All right, well then I'm not going to work through it. If 5% should be the answer, that sounds good to me. All right, let's get back to the packet here. So if you go back up and look, these are the same sorts of problems, so I'm not going to work through these. But I will say, I'll just add to this that if you've ever taken a chemistry class where you've had a lab that you've been in and you've had to use, maybe the chemical reaction that you need requires a certain like acid or something. A lot of times the professor will go into the back into the lab and they'll mix up a batch of acid for you. Like maybe you need like a 3% acid solution. Well, in the back of the lab, they don't have a 3% acid solution. They usually have like, a 2% and maybe a 10% and maybe like a 30%. And what they can do is they can just mix these together in a certain way to get your 3%. Right? They just mix them. Now, that's not what we're doing here. We're not figuring out how much to mix. We're figuring out just what do you get at the end result. So just pointing that out. If you've ever taken chemistry class, that's what they're doing in the back. Okay. The next section or next part of this is mixed practice. So what this is kind of like a mixture of all the problems that we've done in this section mixed up so that you don't really know what you're supposed to do. And so we have to figure out, are we doing, is this a percent increase? Is this a mixture problem? Is this a proportion problem? So let's work through a few of these and see how it goes. Let's look at the first one. Assume there are 425 statistics students at Northwest Vista, of which 35% plan to attend nursing school. If all the students who plan to attend nursing school are enrolled in statistics this semester, what percent of the 15,435 Northwest Vista student body plans to attend nursing school? What? It's a confusing problem when you read it. Assume there are 425 statistics students at Northwest Vista College. 35% of them plan to attend nursing school. So of this 425, 35% plan to go to nursing school. Let's figure out how many students that is. So you take 425 and you multiply it by 35%, which is the decimal 0.35. And I get 148.75. So we're talking about people here, so you can't really have a decimal. So we'll just say approximately 149 people. So these are students that are in statistics at Northwest Vista that intend to go to nursing school. So these are NVC statistics students that plan to go, or plan to do nursing. Understand? It's asking now what percent of the total number of students in Northwest Vista plan to go to nursing school. So we want to know what percent is 149 is what percent of this number. So how do we do that? Take the part, divide it by the whole. And then we should get a decimal. We get about 0.0096. Move the decimal point 2 places to the right. So you should get 0.96%, or approximately, if we round 0.96 up to 1, we get about 1%. How about number 25? Five out of 13 registered voters would actually vote in an election. That means 5 would vote. Not every registered voter votes, right? So 5 would vote out of 13 that are registered. So this is a ratio. We can look at that ratio 2 different ways, with the 5 on top or 13 on the bottom. It's saying how many people would be expected to vote in a town of 5,850 registered voters. So how many people actually would vote? That's X on top out of the 5,850 on the bottom. That must be proportional to the 5 that would vote on top, right? That's why we're using the 5 on top and not the 13, because the top represents how many would vote over 13. I'm going through this a little faster because we've already covered this. So I just want to make sure you understand the process. Cross multiply. So 13x equals, let's see, 5850 times 5. 29,250, and then divide that by 13. You should get 2,250.
Professor, do you usually have these notes posted somewhere?
I can post
like
these.
after?
I can post these if you like. I can post this.
Okay,
Yeah.
thank you.
I mean, you can always go back and look at the video, but I know what you're saying. It's easier sometimes just to look at the notes.
Yes, sir.
Okay, I think I'm going to leave those to you. I think we're at the homework part. So that's going to complete this section. See how you do with this homework. I'm guessing you're going to have some questions. I hope you will have some questions for me when we start next class next time. Okay, I have good news and bad news. The good news, we're going to take a break. Bad news, we're only halfway through the day. So let's take our break, 10 minutes. We'll come back here at 12:25-ish. All right, I'll put up a little timer and we'll be back to continue with new material. Okay, everyone. All right, so I was looking at our calendar and we just finished this section here on percent, proportion, percents, applications, and mixtures. Okay, so that we're done with this. So you should attempt all this homework. Everything else that we had done here, that was what you were tested on. So we're supposed to move on to scientific notation, measurements, prefixes, conversions. What I'm going to do is I'm going to postpone this clump of material here. And we're going to do that at the end. And what I'm going to do is I'm going to get into lines. And then after we do lines, we'll be doing quadratics. And then after we do quadratics, we'll do polynomials and rational functions, exponential and log, and then systems of equations. We'll see about maybe trimming out something here so that we can get back to this. We're not way behind, but I want to get into the graphs and everything else, and this can wait. All right. All right, so just keep that in mind on your calendar to pay attention to what we're doing in class and what I assign at the end of class, because I don't want you doing something we haven't covered. So I'm going to start with lines, and it's going to be in the packet, it's going to be around page 50. So let me get to the packet. Come on. Too far there. Almost there. Okay, here we go. All right, so we are now going to start talking about linear equations. In two variables. Linear equations in two variables. So before I actually tell you what a linear equation in two variables is, let me just remind you that we've already talked about linear equations in this class. We've studied linear equations in one variable when we were doing things like this. Solve 3x minus 4 equals 10. So when we were solving something like this, we noticed that we had an equation and that we had a variable raised to the first power, which made it linear. And so the procedure for doing this, we went through a whole set of steps. You know, you add 4 to both sides, and then you get 3x equals, let's say, 14 here, and then divide both sides by 3, and you get some answer. So notice that we have a solution to this. And if you go back and you look at the class when we did our lecture, I told you when it comes to linear equations, you could have 3 possible answers. You could have a number as an answer, okay, like this. You could have no solutions, or you could have every number as a solution. So there are 3 possible outcomes. But those are linear equations in one variable. So there's only one variable in the equation. What we're going to look at now are linear equations with 2 variables involved. So let me give you an example of a linear equation with 2 variables. X plus y equals 10. So notice you have an equation, right? You have 2 variables and they're both raised to the first power. So that makes it linear. Now, let me ask you, somebody in the class, to give me a solution to this equation. In other words, somebody give me an X and a Y. You give me both. That would make this equation true. So what could I
5
let
and
X be? Say again?
5 and 5.
5 and 5. You could do 5 and you could do 5, right? That would work. Is that the only answer?
No, it's not. You could also do 3 and 7.
3 and 7.
8
One
and
more.
2.
What was that?
8 and 2.
8 and 2.
1 and 9.
1 and 9. Okay. How about, can someone do it with a negative number? Like this. What if I say X is -2? Can somebody tell me what Y would have to be?
12.
12. And what if I tell you that Y is -7? What would X have to be?
17.
17. So look, we could do this all day long. We could actually continue to make a list of numbers. We could spend the rest of our lives until the day we die doing this, right? And we would never finish writing all the numbers that are possible. Yes? So there's an infinite number of answers. Infinite answers. Now, would it change anything if I flip these over? Like if I, instead of the Y being 7 and the X being 3, what if the X was 7? Could the Y be 3? Like, can you switch them and it still is okay?
Yes.
Yes, in this problem, it wouldn't change anything. In this particular problem, the order actually doesn't matter because we're just adding the two numbers together. But let me show you a different example. How about this new example? 2x plus y equals 10. Can somebody give me an example of an X and a Y that would work there?
X could be 2 and Y could be 6.
Okay, so let's see, 2 times 2, that would give you 4. And then if you add 6, you get 10, right? That would work. Here's another one. How about 5 and 0? Wouldn't that work? Right. And again, I could go listing these answers out forever. Can you flip these over? So would it work if I did X's? Let me take that first one. Change the Y and the X values from here. Take this 6, put it here, this 2, put it here. Would this work? Plug it in.
No, it wouldn't. It wouldn't because now you have like the 2 attached to one of your variables.
That's right. The 2 is messing things up. So in general, when it comes to linear equations in 2 variables, in general, your answers that you get for X and Y, the order matters. Like whatever X is and what Y is, you cannot generally interchange them. You might get lucky in one particular example like this one, but in general, you cannot. Okay, so when you have a linear equation, let me get you a new page. In general, a linear equation in 2 variables can be written as some number in front of X plus some number in front of Y equals some number. So like the examples I gave you already were X plus Y equals 10, and then we did 2X plus Y equals 10. Both of these are examples of linear equations. The numbers in front of the X and Y are the A and the B. So the A here is 1, the B here is 1, and the C is 10. 2 is A, 1 is B, and C is 10. So in general, all linear equations in 2 variables can be written this way. And this is what we call standard form. Now, the solutions to this equation are all X and Y's, X's and Y's, which make it true. So that's what that, when we were listing out these X's and Y's, right? The solutions to this equation are all of the X's and Y's that make this true. These solutions are called ordered pairs. Ordered pairs. They're pairs of numbers where the order matters. So like I was saying here, for this example, this first solution is 2, 6, right? X is 2, Y is 6. And we can't flip it around. The order is not, I mean, the order is important. So we can't do 6 and 2. So all the solutions, these solutions are called ordered pairs and are written with the parenthesis X, comma, Y, close parenthesis. That's the way we write the ordered pair solution. So if you go back and you look at the problems we did here, if I wanted to list out these solutions as ordered pairs, then I could write 5, 5. I could write 3, 7. I could write 8, 2. And I could keep going. For this one, I could write 2, 6, 5, 0, right? Those are the ordered pair solutions to the equations. Now, since there are an infinite number of answers, what we try and do is see if there's a way we can visualize all of these answers. Like, is there a way we can visually see these answers? And to do it, we bring in the XY plane. So I know most of you have seen this. We draw a big T or a big cross like this, and we call this the X-axis. We call this the Y-axis. And then when we want to visually represent one of these answers, what we do is whatever the X value is, that's how far we move out on the X-axis, where this is the positive direction, this is the negative direction. And then whatever the Y value is, if it's positive, we go up, negative, we go down. So if I go to some point, if I go to the right by X and go up by Y, then I'll get to a point, and that point represents that ordered pair. I know most of you have seen this, so this is probably not news to you. So let's go back to the problem we had here. And what I'd like for us to do is try and draw these answers. Okay, there's only 2 answers that we've got here right now. Let's try and draw them. Make this a little bigger. Oh, that didn't work. Okay, so 2, 6. That means I go to the right 2. I'm going to say that's 1, that's 2, up 6. 1, 2, 3, 4, 5, 6. So I go to the right 2, up 6. That point, 2, 6, is a visual representation of one of the answers to that equation. Another answer is the point 5, 0, which would be to the right 5, 3, 4, 5. So to the right 5, and then 0 means you don't go up or down. So here's another answer that is a visual representation of that answer. Let's find another answer. Can somebody give me another answer for the X and the Y here? Anything you can come up with other than 2, 6, and 5, 0. How about 1? What if I tell you, well, you know what, let's do 3. What if I tell you that X has to be 3? Can you tell me what the Y is?
Is it 1?
So if you plug 3 in right here, you get 2 times 3, right?
No, it's not. Oh, sorry. I see my mistake now.
Did you square it or something?
I think I did 3 times 3 instead. You would have to put 4 as the Y, right?
This would be the Y would be 4.
Okay.
Good. So if I represent that, let's see, to the right 3 up 4, that would put me here. How about if X is 4? What would Y have to be?
Would Y be 2?
I would be 2. So let's go to the right 4 and up 2. Is anybody noticing anything about all these answers? What do
They form a straight line.
What's that?
They form a straight line.
They appear to all lie on a line. If I were to draw a line, it looks like all of these answers would lie on that line. Is that a coincidence, or is that a property of these equations? Well, it shouldn't be a surprise to you. What are these equations called? What types of equations are these? Linear. We call them linear equations. Why do we call them linear equations? Because when you graph all of the answers, it forms a line, right? That's the whole idea. So if you plotted all the answers to the equation that wasn't a line, then it wouldn't be a linear equation. We'll study those later. So all linear equations, in 2 variables have solutions which form a line. Okay, so Tiffany, let me ask you a question. You there, Tiffany? Not. Diane,
Yeah, I'm here.
you're here? Okay, I just saw your chat. So you good?
Yeah, I am.
Okay, so Diane, I have a thinking question here. If all linear equations in 2 variables have solutions that form a line, then how many solutions would you have to find in order to be able to draw me the line?
2.
Would one solution be enough?
No,
No. How many would you need?
at least 2.
2, right? At least 2, but really only 2, because if you have 2 points, there's only one line that goes through them. So when it comes to trying to visually represent the solutions to a linear equation in 2 variables, we only need 2 answers. 2 solutions is enough to draw all the solutions. Does that make sense? If I only had 2 of these dots, I could draw a line, and that line represents all the answers, right? This line represents all these points that are answers to the equation. So what Diane is telling us, I'm going to write in red, to sketch the solutions. In other words, the line. We only need 2 points or 2 solutions. So the goal of this is going to be, I give you an equation and I ask you to visually show me all the answers. In other words, graph the line, sketch the solutions. Understand? Got any questions on that? what we're trying to do? So to sketch the solutions or the line, we only need 2 points. There are the way we do this is called the intercept method. The intercept method. And here's how it works. It's a pretty simple idea. If I draw a line, no matter how I draw it, that line will have to hit the x-axis somewhere and the y-axis somewhere, unless it's a vertical line or a horizontal line. If it's a vertical line, it's only going to hit the x-axis. If it's a horizontal line, it's only going to hit the y-axis. Okay? But every other line you could ever draw has to hit them both the axes. So I want us to focus on right now a line that's not vertical or horizontal. The point where it hits the x-axis is called the X-intercept. And the point that it hits the y-axis is called the Y-intercept. Now, Deanna, are you there?
It's Dina.
How's it? Dina, okay, yeah, that's right. See, I have to redo this. I remember I put the little dash there, that's right. Okay, make sure it's safe this time. Dina, how's it going?
Everything's fine.
Okay, good. So Dina, I have a question for you. If this point hits the x-axis, okay, think about this. It must have an x and a y, right? There's some x and some y that gets you to that point. Can you tell me something for sure that you know about either the x or y if we're right there on the x-axis?
The y is 0.
The y has to be 0. Very good. Is everyone clear on that? If you are on the x-axis, the y value must be 0. Now the x value could be whatever, okay? But the y must be 0. And then, Dina, for the y-intercept, what can you tell me about that point?
The x is 0.
The x must be 0, and the y, well, that could be something else. Okay, good. Thank you, Dina. So when we're going to try and graph a linear equation in 2 variables, the intercept method says, hey, just go find these 2 points. And once you find them, draw a straight line. So to find them, here's what we're going to do. To find the x-intercept, what you're going to do is you're going to set y equal to 0 and then solve for x. The reason why we set y equal to 0 to find the x-intercept is because of what Dina just said. If we're trying to find the x-intercept, we know the y value must be 0. So we just replace y with 0 in the equation and then solve for x. If we want to find the y-intercept, well, just like Dina said, if we're trying to find the y-intercept, the x must be 0. So we set x to 0 and then solve for y. Let's do an example, all right? This is just the setup for it. I'm just giving everyone a moment to write that down, just in case. All right, here we go. Let's take that problem. I want us to sketch 2x plus y equals 10. Now, when I say sketch, what I mean is show all the solutions. That's what it means. To sketch this means to draw all the solutions. We look at this, we have to realize we're looking at a linear equation in 2 variables, and we're going to use the intercept method. So first, let's find the x-intercept. So we're to find the x-intercept, Bonnie, what do we do?
We said y equal to 0 and
Set
solve for
y
it.
equals to 0. Okay, so I'm going to write the equation down. I'm going to replace the y with 0. So replace that y with 0, which just leaves me with 2x equals 10. And see, now we just have an equation with one variable. Because y is 0, it's gone. Now you're back to what we did before. Solve this equation for x. Divide both sides by 2. And you get x is 5. So our x-intercept is the point 5, 0. X is 5, and y must be 0 because it's the x-intercept. Any questions there? We need the y-intercept now. So Darshell? Am I saying that right,
Yes,
Darshell?
sir. Yes,
Okay.
sir.
Okay. You following okay here?
A little bit.
Okay. So
Not
to-
even gonna lie. I'm trying to get it.
Yeah, to find the y-intercept, what do we do? So to find the x-intercept, we set y to 0.
So to find the y-intercept, we set x to 0.
Set x to 0, yes. Okay, so we're going to rewrite the equation 2 times 0 plus y equals 10. The 2 times 0 is gone, so you're just left with y equals 10. And that means that the y-intercept looks like this. The x was 0 and the y was 10. Now I'm ready to.
Oh,
graph. Go
I'm
ahead.
sorry. This is Bayla. I have an off-topic question. Did my camera go off?
Your camera is not on right now.
Okay, I'm sorry. I'm just having technical difficulties. I needed to know.
Okay. No big deal. You're here. I'm counting you as being here. You participated, so you're good.
Cool. Thank you.
All right, so now time to graph it. So I'm going to go and draw this. I need an x-intercept of 5, 0. So I'm going to go to the right 5. 1, 2, 3, 4, 5. Here's 5. I'm going to put a dot here. And then my y-intercept is 0, 10. So I just go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it's way up there like that. And that's it. I have 2 points. Once I have 2 points, I just connect them with a straight line. Maybe. If it lets me. It's not letting me. Okay, that's gonna have to maybe be good enough. Yeah, I don't know why it doesn't want me to do that. All right, there it is. There it is. Okay. So given a linear equation in 2 variables, we can find all the solutions by sketching the line. To do that, we can use this thing called the intercept method. You find the x-intercept by setting y equal to 0 and solving. You find the y-intercept by setting x equal to 0 and solving. So I'm going to now give you 3 problems to try on your own, and they're going to get progressively harder. All right. So I would like for you to sketch all of these. So problem A is going to be 4x minus 3y equals 12. B is going to be negative 2x plus 5y equals 10. And C is going to be 1/2 x minus 3y, or sorry, plus 3y equals 1/3. All right. So you can see they start getting a little harder because you got fractions there at the end. I want to see that, everyone can get at least the first one. And then the second, maybe. The second's going to be a little weird. And then see if you can get the third one. Now, I know that not everyone here has graph paper. Just do your best to draw, okay, to the best of your ability. And yeah, I'm going to do this a little different. I'm going to put you all in breakout rooms. And that way you can work together. And I'm going to give you all probably about, I don't know, 10 to 15 minutes to see if you can get through all three. Help each other out, okay? I know it's hard in Zoom, but at least y'all can check with each other. Say, hey, are y'all getting this for the X-Intercept? Are you getting this for the Y-Intercept? Oh, what are you doing? I'm doing this. Try and help each other out, okay? And so I'm going to invite you to a breakout room. There's going to be anywhere from 3 to 4 people in the room. We'll see how this works. This is the first time we've done this, so we'll see how it works. And I may jump into each room and kind of like check on you. And then I believe when you're in the room, you should be able to ask for help. You can like raise your hand and it'll let me know if I'm not in the room to go help y'all out. All righty, here we go. You should get invited. Make sure you copy the problems down before you leave. Hey, Caitlin, are y'all done or what?
My sound wasn't on. We're done, but like we were kind of confused if like we were gonna be called back or if we just had to like leave.
Yeah, I was gonna call y'all back. I'm just finishing.
Okay, my bad. I'm so sorry. I was the test bunny. They were like, you go first.
Yeah, no, you can just stay here. I'll call everyone back. Hold on, let me see how much is left on my timer. Hold on.
Okay.
Okay, we're gonna go another like 2 minutes before I pull people back, Caitlin.
Okay, sounds good. I'll just hang here.
Okay. So how did that go for y'all? Did y'all find that to be productive or?
Yeah, I mean, it was pretty easy on my end until it came to the fractions, but so far my group actually got it right. So, and we worked together, so it was really good.
Good. Did y'all like being in the group breakout, or does it not really matter? Yeah. Well, we'll try it some more and see, and I'll take a poll later and see if y'all want me to continue to do that. Okay, so here's the answer for part A. You get the x-intercept of 3, 0, y-intercept of 0, -4, plot it, draw a straight line. So does anyone have a question on part A? Anyone not get that need clarification? Okay, part B, same thing. X-intercept comes out to be a nice number, -5, 0. Y-intercept turns out to be 0, 2. So there's your graph. And then we'll get to part C. Part C is the weird one. So when you find the x-intercept, you set y to 0, which leaves you with the 1/2 x equals 1/3. And now you need to get the half out of here. So one thing you could, I mean, there's two different ways you could kind of go about this. You could take 1/2 x equals 1/3. You could divide by a half. That's fine. But then on the right side, you're doing 1/3 divided by 1/2, which equals 1/3 times, this is where you keep dot flip. You flip that fraction over, you get 2/3. Or you could just multiply both sides by 2 instead of dividing by a half. And then the 1/2 and 2 cancel. And then here, 1/3 times 2, you just multiply straight across, 2/3. So you get 2/3 0 is the x-intercept. Y-intercept, there's a similar issue. Let X be 0, you get 3Y equals a third. I divided both sides by 3. And then I rewrote 1/3 divided by 3 is 1/3 divided by 3 like this, then keep dot flip. And that multiplies straight across to be 1/9. So the graph on this one's going to be a little weird because like 2/3, where's 2/3, right? So if you don't know what 2/3 is, you can do your calculator. It's like 0.6666. So you could say like if this is 1, then 0.6 would be somewhere around here. I'll just say that's 2/3. All right. And then your y-intercept is 0 1/9. So 1/9 is like 0.11111. So if this is 1, 1/9 would be like way down here. So you just eyeball it, okay? You don't have to get this perfect. That's 1/9. And then you draw a straight line through those. Whoa, straight line. Okay, straight enough. All right, any questions before I move on? Okay, 2 special lines. Vertical and horizontal. All vertical lines that go straight up and down, are written x equals a number. All horizontal lines are written y equals a number. As an example, if I write x equals 3, then when you graph this, you go out to x equals 1, 2, 3, and you draw a vertical line that goes through x is 3. Whereas with a horizontal line, if you write, let's say y equals 3, then what you do is you go up 3 on your y-axis and you draw a horizontal line. So do vertical lines hit the x-axis? Yes, right? Do they hit the y-axis? No, unless it's right on top of the y-axis. But other than that, you only have an x-intercept. And so that means your equation is just going to have x in it. There's no y's in this equation. Then here, for a horizontal line, you only hit the y-axis, and that means your equation will only have a y in it. So just be aware that those are the 2 special lines that we have. Okay. Now, let me get to the packet again. Let's take a look at where we are here. Okay, so this is the homework for this section. First thing, find 3 different solutions for the following. So you're just going to pick some answers like x's and y's that make this work. This one, same thing. Here it says find the x and y intercepts for the following. So you're just going to be, to find the x-intercept, you let y be 0. To find the y-intercept, you let x be 0. And then you start graphing. So this is kind of like the problems I gave you to work on. Here, see, this one has fractions in it, so be careful. What kind of line is this? We only have x's there.
Vertical.
Vertical line. Okay. All right, so let me see. And I want to see how you do with that. I don't want to talk about that. Okay, so we're ready to move on. Oh, all right. So now we're still dealing with linear equations in 2 variables. there is another way to sketch a linear equation in two variables. Okay, there's another way to do it. So right now, what we've looked at is we've looked at linear equations that look like this. Right, that's the standard form. Now, if you take the standard form and solve for y, you get a new equation which looks like this. Y equals mx plus b. And this is referred to as the slope intercept form. Okay, so we have the standard form, and then we have what's called the slope intercept form. The only difference between the two is that the slope intercept form, you take this equation and solve it for y. So for example, let's take the first problem that we graphed. Remember we did this problem? It was the first one we did together. I said, hey, let's sketch this. That was this problem right here. I said, sketch this, right? And we did the intercept method and we said, boom, boom, we got our 2 points, drew a straight line. The other way we can sketch this line is to first turn it into what's called its slope intercept form, which just means solve for y. So if I wanted to get y by itself right here, what I would do is I would subtract 2x on both sides. That would leave me the y on the left, and on the right, I'd have 10 take away 2x. Now I cannot put those together. This doesn't become 8x because this has an x, this does not. So these are not like terms. What I want to do is try to make it look like this, which means it should be y equals, which I have, y equals some number in front of x and then plus some number. So I'm going to just flip the order and make this negative 2x plus 10. This is the slope intercept form of that line. And you should be able to do that for any line as long as it's not vertical. Okay, so if it's a vertical line, you can't do this, but if it's any other line, you should be able to solve for y. Now, what makes this form nice and what makes it easy to sketch is the following. This number that's back here is always going to be your y-intercept. Always, all right? So whatever number's in the back, here in this case, it's positive 10. That's our y-intercept. And then the number that's in front of x, okay, just the number in front of x, not x itself. This is what we call the slope of the line. Now the slope, what the slope is your rise over your run. And that just means it tells you as you move from point to point on the line, how much you have to go up and over to get to the next, to another point. Okay, now I'll explain this as we do this example. This, for this line, the slope of this line is equal to, so m is what we call it, right? M is equal to -2. And since the slope is rise over run, I can rewrite that as -2 over 1. I can write it as a ratio, as a fraction. That way I can see that the rise is -2 and the run is 1. So how do we use that information to graph? Let's see. What we do is we start, the first step is always to look at what the y-intercept is first. So the y-intercept for this line is 10. So that means I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And right there, I will draw a dot. That's my y-intercept. Now, to get to another point on the line, I now use the run. I mean, sorry, the slope, -2, which tells me I go down 2 to the right 1. So when it says rise, normally you would think go up, but because it's negative, I'm going to go down. So I'm going to go down 2, and then run is left and right. So to the right means positive, to the left means negative. So I'm going to go right 1. So this really means for me, I'm going to go down 2 and right 1. But the important thing is I have to start at this point right here. So I go down 1, 2, and then I move to the right 1, and I draw another dot right there. And if I did it again, I could go down 2 to the right 1, I would have another dot. And if we put all these dots together, we have the line. Now this might appear, at least to you, to be harder because you have to move things around. But later on, you'll see that most of the time when we deal with lines in other classes, it's usually in the slope intercept form. Like that's the way it's given to you. So we want to be able to work with them. So I'd like to go back to these questions here. I'd like to see if we can take this problem and do this one. So I'd like to sketch this one using the same slope intercept method. So I'm going to solve for y first. So subtract 4x here, subtract 4x here, goes away. I'm left with -3y equals 12, take away 4x. Now on this problem, I have a -3 in front of the y, so I'm going to divide by -3, and I have to do that to everything. And that leaves me with the y on the left. 12 divided by -3 is -4. And be real careful on this next one. We have a -4x divided by a -3. A negative divided by negative is positive. And then I'm going to write it this way. 4/3 in front of the x. So I just kind of put the 4 and 3 as a fraction and placed it in front of the x. And then I'm going to just rearrange things so that it looks like a number in front, and then this right here will be the b. Are there any questions on me solving this? So now time to graph. Where do I start? Where do I start? What's the first thing I put on my graph? Always start with the y-intercept, okay? Always start there. So I'm going to go on my y-axis, I'm going to go down 4. 1, 2, 3, 4, there it is. -4, put a dot. Be careful, it's the y-intercept, not the x-intercept, okay? In this formula, in this standard, or sorry, the slope intercept form, this is always the y-intercept that you have, this number. Now, to get to another point, I'm going to use the slope, that it's 4/3, and that's my rise over my run. So that means I want to go up 4 this time because it's +4, and I want to go to the right 3. So from here, if I go up 4, 1, 2, 3, 4, and to the right 3, 1, 2, 3, I will land right here, and then I can just connect those with a straight line, and that should match the answer we got before. Okay, what do y'all think of this? I know some of you have seen this before in the past, so that's why maybe it's been a while, but so let's take a look at, we keep doing that. Let's take a look at packet here. Okay, why don't I give you a minute, couple of minutes. We only have about 13 minutes left. Why don't we take the next like 5 minutes to see if you can find right in slope intercept form. Let's do 1, 3. Let's see if you can do 7. In other words, solve each of these for y and make it look like y equals mx plus b. Don't bother drawing them right now. Just see if you can solve for y. And we'll take about 5 minutes for that. I put the answers to the first ones there, but I haven't done the last one. I'm going to talk about that one when the time is up here. Okay, I think that's enough time. I put the answers to number 1 and number 3 there. Hopefully you're able to get those. I am going to go through this other one though, because this one's a little bit tricky because you're trying to solve for y. And so I'm going to take the 1/3 x and subtract it on both sides, which gives me a negative 1/3 x on the right, and I still have over there a 2/3. So hopefully you're able to get to that. The next step is the hard part, I think, because you have to divide everything by -2 to get this -2 out of here. So you could do that. You could come in here and say, divide this by -2, divide that by -2, divide that by -2. But if you do it that way, you just need to realize that like this really means -1/3 divided by -2/1, and then do your keep dot flip. So this would be -1/3 times 1/2. And so when you multiply straight across, you get -1/6, which is just 1/6. I think that's the trickiest part, just keeping track of these fractions. Y equals 1/6, and then you still have x there. And then you have to do this one, which is going to be 2/3 divided by -2, which is 2/3 keep dot flip, which is 2/6, which reduces to be 1/3. So 2 goes into both of those. And then I'm going to write that, remember we talked about the minus sign on the bottom. It can be on the bottom or the top or out front. So I'm going to move it out front, -1/3 like that. Okay, can I clarify that at all? Or is that clear to everybody? Does anyone have any questions there? It's not the only way to do it, but I'm just trying to show you like that is a way to do it. If I were doing it, I would just multiply both sides by -1/2, but trying to be consistent with what we've covered in this class already. Okay, let's talk real quick about homework. So again, we are going to be skipping this right now. So for homework, you should be looking at this homework assignment, page 53, 1 through 15 all. And also the homework assignment up here for percents and proportions, all of that. Those two are the main homework assignments. Don't get started on the next session. That's the slope intercept method. That's what we're talking about right now. Let's not do that yet because we haven't gone through all the material yet. So let's just hold off on that. We'll knock that out at the beginning of class next time, and then we'll be able to move on to the next topic. Okay. Everyone got that? Page 19, 1 through 37, and page 53, 1 through 15.
Sir, I'm sorry. Can you repeat the numbers on page 19?
1 through 37.
Okay, thank you.
Okay. I'm going to cut it out of class right now. I'm going to end class. You're free to go. And if anyone has any questions, I'm going to hang out for a few minutes. I know some people I need to talk to about the exam and things like that. So what is it? Wednesday? Have a good weekend, right? Have a good weekend. I'll see you on Monday. Everyone have a good.
You too.
You too, sir.
Thank you.
Okay. Take care.